You good?
From random German things in my German notebook. Ich will deine Mutter. I want your mom.
This is something to me.
What does that mean? I want your mom. I want
That's a choice. We're just gonna go with that's a choice. All right. I still see a bunch of you writing, so I'm gonna leave it up for another minute or so. But we're gonna practice with this. We're gonna use this a lot. A lot. I think every day this week we're gonna be using this. Okay. I'm holding. All you gotta say is hold on. I hear the most random pieces of conversation that just waft over. Waft was the word in my brain, and I combined it with wash. Wash and waft combined to be wasp. They wasp over. Grammar is a construct and spelling is a suggestion. That's what I'm going with. Words are a suggestion as well. When in doubt, go full Shakespeare and make something up. All right, ready? Okay. 3, 2, 5, 4, 3, 2, 1. All right, changing it. I even have the fractiony thing still up here. So what we're going to do is we're going to take factors of the constant. We're going to call it P over factors of the leading coefficient. We're calling it Q. So in this particular function, that is a Q.
Whoa. It looks like P sideways. You should do a
Better?
capital Q.
Capital Q means different things.
Oh, what?
I mean, it's fine. Like, it's fine with me if you use it. But that's why sometimes I can't, because capitals and littles mean different things. Okay. So the constant is P. On this particular function, what is our constant? The 6. So this is our P. What is Q? 2. So it's just about the constant at the end, the very last. Our leading coefficient is the number in front of our biggest exponent. So we're going to think about P, our 6 here. What are the factors of 6? 2, 1, 3, and 6. What are our factors of Q? 1 and 2. What we're going to do is make a list of all possible rational zeros, which is every possible combination of P over Q. You may entirely possibly have. So our list of all possibles, and you can organize this in whatever way works for you. I tend to do P over Q and do like 1 over 1, 1 over 2. Then 2 over 1, 2 over 2. But if you want to do all the things over 1 and all the things over 2, I don't care how we organize it. So our all possibles is going to include plus or minus P over Q. So I'm going to have 1 over 1, which is 1. And then plus or minus, I'm going to take that 1 over 2. 1/2. plus or minus. Now I'm going to go on to my next possible p factor. 2 over 1, which is 2. And plus or minus 2 over 2, which is 1, which I already have written down. I don't need to write it again. See how we're getting these? It's always going to be plus or minus every single time. Our roots are going to be plus or minus for whatever we have. For everything. It's plus or minus on every possible term.
How did you get the 1/2?
Oh, the 1/2? 1 over 2. P over Q. Sorry, I got caught on the plus or minus, not the 1/2. So then so we did our 1 over 1 and then our 1 over 2. Then we did 2 over 1, 2 over 2. 2 over 2 is still the 1 again. So next I'm going to do my 3 over 1. So plus or minus 3. And then 3 over 2. Do I have that in my list yet? Nope, so we're going to put that one in. So then we're going to do 6 over 1, so plus or minus 6. And then 6 over 2, which is 3, which I already have. So for this polynomial, our roots, our zeros, our solutions are somewhere in this list, which is significantly fewer options than all real numbers. So sometimes our lists are going to be obnoxiously long, and this one is actually fairly short, just to give you a warning of how long some of these are. This is fairly short. But so when it says list all possible,
No, but like, is this the end of the problem?
this is the end of the problem here.
Oh, we don't have to figure out which deal maker.
Not yet.
When will we have to? Today?
Yes.
Okay.
But I'll walk you through it. But we're going to start with making our list. We're going to make this list a couple more times before we start playing with it. So here's our next function. Sorry, I'm trying to write my cues in the way you guys like, and it's hard for me to not connect my cue up. All right. How about we do the next one like that? Okay. So what's our P? 12. What are the factors of 12? Yep. 1, 2, 3, 4, 6, and 12. What is our Q? 10. What are the factors of 10? 1, 2, 5, and 10. So this is going to be a long one. Still not the longest, but definitely a long one. This reduces the number of options we have from all real numbers to this, it's called a finite list. It reduces the number of choices. So when we do go to find all real zeros, we have a list that helps us figure it out. So it is, in fact, something we are going to use and something helpful. So our all possible options, I'm going to do my 1 first, so 1 over 1, so plus or minus 1, 1 over 2, plus or minus 1/2, plus or minus 1 over 5, plus or minus 1 over 10. So we're going to have fractions. So then I'm going to use my next factor of p. So 2. 2 over 1. Well, that's just 2. 2 over 2. That's 1. It's already on my list. 2 over 5. That one's new. So we're going to put plus or minus 2/5. And 2 over 10. 1/5, already in my list. I don't need to write it down. Then I'm going to go to my next factor of p, 3. 3 over 1, plus or minus 3. 3 over 2 is not in my list. So we're going to put that in here, 3/2. Plus or minus 3/5, and plus or minus 3/10. Neither one of those will simplify into something we already have. And I'm going to make a second row because I've run out of space already. So we're going to have plus or minus 4. 4 over 2, we already have, because it's 2. 4 over 5, that one we don't have, so we got to put that one in here. 4 over 10, we already have, because that's 2/5. So we're on to 6, plus or minus 6. 6 over 2, we already have. 6 over 5, we don't have, so we're going to put that one in our list. 6 over 10, we already have, because that's 3/5. So then we're on our last one, 12. Plus or minus 12. 12 over 2. 6, which we've got. 12 over 5. We don't have. And 12 over 10. 12 over 10 is 6/5, which we do have. 12 over 5. It was my P over Q. So 12 over 5. So I'm listing all my P's over all my Q's. All my factors of P over all my factors of Q. Why aren't we doing what? Simplifies down to B, or as an improper fraction. You can simplify it down to B/5. And 6/5 we already have. Okay? So listing all of the possible zeros, it's a matter of kind of a long list and exhaustion. But there's a promise, a reason we use it. Yes, dear. 12 over 10, simplify it.
Oh, 2.
Which is?
6 over. Okay. I was doing 3 and 4. And what? I don't know.
That's okay. That's okay. When in doubt, ask. And you can always write it down, but you might give yourself extra work later on. So you can always have it there, but it is going to be easy for you to simplify it. Okay? So the reason we want to be able to do this is because we're going to take problems like this and actually find all of our solutions. And the list makes it so I don't have to blind guess into the universe of all real numbers, because all of my roots are here somewhere. Or at least all my real roots are here somewhere. How many roots will this one have? It's going to have 5 roots somewhere. We don't know how many are real. We could use the Descartes rule of sign to see how many are positive, how many are negative, that kind of jazz. But all of our real answers are here somewhere. They're here. We just don't know which ones they are. I'll show you. So this is going to be the first one where we find all of the answers. So we are going to find all real zeros. So it's going to combine with a whole bunch of stuff we've done before. So first thing we're going to do is we're going to list all possible roots. So I want you to make your list. But we are going to get all the way down to the answer. Oh, sorry, my screen freaked out. So what are our possible answers here? Yes. So plus or minus 1, plus or minus 2, and plus or minus 4. Because it's the factors of 4 over the factors of 1. How many roots is this going to have? Total. 3 total roots, because it's a cubic, right? I have 6 real options here. So we're going to start with seeing if we can kind of narrow down. And we're going to do Descartes, what we did on Friday, how many positive changes, how many negative changes. So for our possible positive real roots, how many do we have? 1, because there's only 1 sign change here. So 1 positive root. To figure out how many negative roots, what do we do? The opposite of x. So the opposite of x when cubed, because it's negative x cubed, minus 2 opposite of x squared. So that doesn't change my sign. If I substitute the opposite of x into minus x7, minus 7x, change the opposite. This is substituting in f of minus x. Just remind us. Minus 4. How many sign changes are in the opposite of x? 2 changes. So that means how many negative roots do we have? 2 or 0. Because it's always down by an even number. So it's either 2 or 0. Because that's part of the Descartes rule of sign that we did on Friday. So like if we had 3 on this one, it would have been 3 or 1. If we had 5, it'd be 5 or 3 or 1. It counts down by 2s. So we know it's going to have a positive root, and it might have negative roots. So what we're going to do to figure out which of these roots work is we are going to play the guess and check game with our possible roots. I know we're going to have a positive root, so I might go with the positive ones. We also only have 6 options, so... And what we're going to do is we're going to substitute those in. F of, which root do you guys want to start with? 1. And we're going to substitute in 1 to our original function. If it's a root, what's our answer going to be? 0. So if we get anything other than 0, it's not a root. So when we substitute in 1, let's see what we get. 1 cubed minus 2 times 1 squared minus 2 minus 7 times 1 minus 4. Is that going to be 0? No. Do we really care what the value is? No. We just can tell already, not 0. That's definitely a negative number. So we know it's not positive 1. Yes, dear.
Why is that first number positive? I thought it was.
So we're substituting it into this one.
Oh, the top one.
Yes, into the top one. This is only used for the Descartes rule of sign. We're not going to use it for anything else. It's just telling us how many negative roots. We didn't freak out. Okay. So which root do you want to do next? 2. Sure, let's do it. F of 2. 2 cubed minus 2 times 2 squared minus 8. 7 times 2, 14, minus 4. Is that going to equal 0? Nah. We're going to wind up with negative 18. Okay, so I know it's not positive 2. What else we got? 4. So let's do f of 4 and make sure it works. 4 cubed. 64. Minus 2 times 4 squared. 32. Minus 7 times 4. 28. Minus 4. What do we get? 0. That tells me that 4 is a root. 4 is a root. Since it equals 0, we know it's a root. So then I need to divide out that root of 4. So we're going to use synthetic division. Hang on, can't hear you. Because now I know that that's a root, I can remove that root and see what's left over. Because we're not just finding a root, we're finding all roots. So I know that 4 is a root. I don't want to have to guess and check every possible answer forever and ever and eternity. So we're going to divide out 4. So I'm going to use my synthetic division. All of this for one problem. I'm just going to say, oh, just you wait. This is just a cube. They get longer. I think the longest one we're going to do is a 5th. We're not going to have like 8 of them.
We're gonna have 1.
That's still gonna take us like a long time to go. But this is
I know. This is also our very first one. We'll get better.
Are we going to use the original function?
We're going to use the original function. So we're going to list our coefficients. 1, negative 2, negative 7, negative 4. I'm going to assume that I'm changing the view just so that it's not so tiny. So we're dividing 4. These are our coefficients. First term always drops. What's going to go here? 4. 1 times 4. Then we add. Negative 2 plus 4. 2. 8 goes in the next spot. And we add together, get 1, 4, and our remainder is 0. So our function that we have left Remember, this is our constant, our x, and our x squared, right? So we have x squared plus 2x plus 1. And we're looking for the other roots. What can I do with an x squared that I couldn't do with a cube is factor. So we're going to factor this guy. What are we going to get when we factor this? X plus 1, x plus 1. So what are our roots? So we have x equals -1. And what's our other root? X equals 4. X equals -1 has a multiplicity of what? 2. Multiplicity. I can't spell it. Because there's 2 of them. Multiplicity 2. So my roots are -1 and 4. -1 has a multiplicity of 2. We could write this in fully factored form. X plus 1 squared times x minus 4. And we can see that -1 is still in our list of possible real roots. And we got 2 negative roots. Yes, dear. It just means it's a double root. That's exactly what it means. Okay. Let me see how long the next one is before I commit us to it. That is the end of this one. We have found all our roots, and we even wrote it in factored form. It was just the roots. The question was find all real zeros, so we're just looking for, and I'll highlight it as soon as my highlighter stops being a jerk. This was all they asked for in our answer. All right, let's do one more of these. It's of a similar length, so it's not the giant list today. All right, so we're gonna do this one. It's a slightly longer list than the last one, but other than that, it's almost the same. 2x cubed plus 11x squared minus 7x minus 6. All right. And you can go through this in whatever order you want. If you want to start with Descartes, that's fine. If you want to start with your list, that's fine. It does not matter in what order you start. So I'm going to start with my list. So what is my P? 6. So what are my factors of P? 1, 2, 3, and 6. Yes? It doesn't change what's going to happen in our list. It's always going to be plus or minus everything. How about what's our Q? 2. And so 1 and 2 are our possible factors. So our list of all what are we going to have?
Plus or minus 1, plus or minus 1 half, plus or minus 2, plus or minus 3, plus or minus 3 halves, plus or minus 6.
Yes. Plus or minus 2, plus or minus 3. So make our list of fractions. And we should get this as our list of all possible options. The reason we want this list is so that we know which values to choose from when we're trying to substitute in. This is our list for substituting in for our guess and check portion. Otherwise, we're just guessing randomly from all possible real numbers, and the chance of us guessing one of these fractions is incredibly low. So let's figure out how many roots of each sign we have. How many possible positive roots are we going to have? 1. Because we only have one sign change in our original function. And I'll put it up here so it doesn't confuse us. Our f of minus x, when we substitute in our minus x, so the opposite of x cubed is going to change the sign, minus 2x cubed. It's not going to change the sign on my x squared. It is going to change the sign on my 7x, but it is not going to change the sign on my 6. So how many possible negative roots are we going to have? 2 or 0. So we know we're going to have a positive root, and we could have 2 negative roots, or we could have 2 complex roots. So my recommendation always is, if I know I've got a positive root, let's substitute in positive numbers because I know one of them is going to exist. Otherwise, I could substitute in all negative numbers and never find a root because we don't know that there even is one. So we're going to substitute into our function rule. What do you want to start with? 1. Always an easy one to start with. So 2 times 1 cubed is 2. 11 times 1 squared is 11. Minus 7 minus 6. And what do we get? 0. What does that tell me? 1 is a root. So we lucked into a root on our very first one. 1 is a root. Yay, we lucked into one on our very first try. So we're going to divide the 1 out of our function. So I'm going to do my synthetic division. You could do long division, but long division is longer. So I'm going to take my 1 into all my coefficients. 2, 11, minus 7, minus 6. First term always drops. What's going to go up here? 2. And below? 13. Which means here is 13. And below? Which means up here is 6. And we get a remainder of 0. It's another way to confirm that we did in fact find a root. Our remainder should always be 0. So this gives us, changing this so that we have space again. Our quadratic portion is 2x squared plus 13x plus 6. That is what's left over when we divide out the 1. Now what can I do to figure out what x is? See if we can factor it. Absolutely. So we're going to have our 12 and 13. What's a pair of numbers? Multiplies to be 12, has to be 13. 12 and 1. So since I have an a value, we do need to at least write something out. 2x squared plus 12x plus 1x plus 6. I had a lot of people on the last one not write this step out and just go straight into like x minus 12x minus 1 or x plus 12x plus 1, which means your a value has changed. So you can't skip this step if your a value is not 1. You got to write it out in factor or box or something. But don't ignore the a value just because we don't like it. Because this one, when we factor this, I'm going to factor with our grouping. We're going to have our 2x plus 1, and our leftovers are x plus 6. So what are our roots? X equals negative 6. X equals negative 1/2. And what's our third root?
1.
X equals 1. Okay, so these are our roots. And you can see that we do have our 2 negative roots. And our 2 negative roots are in our list of options. Negative 1/2 and negative 6. Our 1 was way over there. Okay, we're going to continue working with this tomorrow. It'll have more exponents tomorrow. What's up? Okay, I'm coming. All right, so I'm going to put this up there. So,
And she was like, oh,